Hi, this is Phil from Simply Rhino. This is the third and final video in the tutorial looking at creating production quality surfaces from 2D design intent. The starting point for this exercise is a series of 2D drawings presented in Adobe Illustrator. We'll look at quickly reconstructing some of the major construction curves in Rhino before producing a series of surfaces from the minimum of curve input. The emphasis is on creating high-quality surfaces relatively quickly before arriving at the final 3D solid model. This tutorial is in 3 parts, and this is the third and final part. Okay, so now we can start to think about trimming up our surfaces. So let's first of all trim the outer body side with the top surface. So we use the trim tool. Type in CRV to enable the curve filter, pick the edge of that top surface and trim away the outer body surface. Repeat the process on the underneath. Okay, and now that's the main outer surface. Let's kind of repeat this process for the inner. So let's take these off. Turn on the inner surface and top surface inner. This time I'm going to generate an intersection curve from these two objects and trim with that. This makes it a little easier for me to see where I'm trimming, and in cases where the geometry gets difficult, it means that I've got a better chance of being able to create a clean trim. If we go to the right view here, turn on the section, we should be able to then take a curve or a line from both sides and trim away the underneath of our body and then create a surface from planar curves on the underside here. So that's my inner surfaces of the pot. Now I'm not going to join these together at the moment because we need to join the spout inner and outer separately. So I'm going to look at joining the outer side of the spout first of all. So I'm going to turn on the body surface outer and the spout surface outer. And first of all, let's trim these up with each other. So pick the spout and the outer surface, generate an intersection curve and trim with that intersection curve. Join together and check this is watertight. Using show edges with naked edges, and just pick a nice bright color here. Make sure we don't see any of that color along the edge. So next I'm going to add a blend down each of these two sharp edges here, and I'm just going to check that this front surface is joined onto the other two components here before I do this. And I'm going to go to solid, fillet edge and blend edge. I'm going to use a 4mm radius, and I'm just going to pick one of the edges first of all and just turn on the preview. Take a look what this looks like. And the 4mm radius is commensurate with what's going on the outer edge of the handle. So add that, and next I can add a smaller blend around the junction of the spout and the body. So I'll go to fillet edge and blend edge again. I'll try 2 first of all. I'll use the chain edges option to pick all the edges at once and enter again to get into preview. And 2 things I need to do here. First of all, change the rail type to distance between rails. This will give me a consistent looking fillet here where my angular condition is varying. And I'm just going to try and see if I can increase this slightly. If it's too big, it's going to fail. That looks good, 2.5 millimeters nominally there. So let's take a look at that. Now it's important with a blend like this that we do two things. First of all, we want to check that this is watertight around there, and we also want to check this with an environment map, just to make sure that that's nice and smooth. Okay, now I don't want this blend to be too big, I want it to be nice and tight because the overall product is quite crisp, and that looks okay. So now we can move on to looking at the inner surface of the spout and joining that to the inner surface of the pot. Before we join the inner surface of the spout to the inner surface of the body of the pot, I'm going to turn on the inner surface of the spout and just temporarily join it to the rest of our assembly, and then add a small blend on the inside. So this blend radius here was 4 millimeters. Our wall thickness is 2.5 millimeters. So we should have a 2 millimeter blend on the inside of here to make this look consistent. So let's look at adding a blend edge here. Type in a radius of 2, and I'm just going to pick an edge here, and I just want to change the rail type here to rolling ball, which was the same type that was used on this outside edge, and let that build. Okay, and that looks nice and consistent there. You can see that this wall now looks a consistent thickness. Let's repeat the process over here, and that looks okay. Just check in here for any naked edges. Okay, that's all right. And then I'm going to just detach this surface here and show in the inner surface of the body. Okay, take the inner surface of the body and the inner surface of the spout, go to my standard menu and visibility, and just show just those objects, and just generate an intersection curve between these two and trim away the respective parts. Okay, and join this together. Just get rid of the intersection curve first of all, and join this together. And check for any naked edges. Okay, so clearly I didn't join those together in the first place. Right, okay, so that's better. So that's joined correctly. Now we could put a fillet around this inside edge, but it's really not necessary. As I said, we're really using the creating a B surface purely so that we can create a solid model, and more important, so that we can work out things like the lid detail. So let's show in the rest of the geometry now, and now let's look at the base surface, and then let's join the base surface to the rest of the geometry, once again checking for naked edges. Okay, so we've just got the top to look at now and the handle. So even though I've just joined this all together, I'm actually going to just extract this part of the surface here and go to my visibility tools again here and use invert and hide, and I'm going to bring in the handle now, and I'm going to consider just joining these two together. So we can do this again with an intersection curve. So curve from objects, intersection, pick the curve and trim away the handle and the inside part of the outer surface. The handle is going to be solid. The handle doesn't have any thickness because clearly there isn't enough room here to get a 2.5 or 3 millimeter wall thickness in here. So this handle would be a solid piece. Trim this away. And join together. Just delete those curves and check for any naked edges. And now we can add some blends where the handle runs into the body surface. So solid, fillet edge, blend edge. I'll use a 2mm blend here. Use the chain edges option and take a look at this. So that looks okay with the environment map. And then we'll just run the show edges on here just to make sure that's all joined up. And then we can repeat that same process at the bottom edge. Once we've repeated the blend around the lower part of the handle, we can just check again for the integrity of this. That looks fine. Let's then add the final components. So I'm going to show everything back in again. Just hide the what remains of the outer part and turn on the top surface inner, and just make sure that we can join this together. Okay, that's fine. And then show back in the outer body and then the top surface outer. Okay, and select everything now and join, and you'll see in the command line here we get confirmation that that's joined into a closed surface. So now we've got our basic sort of solid, and we need to add some minor blends to these sharp surfaces, and again we can just check these off the plans and elevations here. So I'll turn on elevations in place and side elevation, turn off the side cross section, and see if we can get a measurement from this radius here. So again it varies, but it's approximating 1 millimeter. So let's put a blend edge with a radius of 1 millimeter along this bottom edge, and let's put one here as well. There isn't one shown on the CAD, but this wouldn't be sharp, so let's make this a 0.5 blend. Just take a look at this. Okay, so that looks fine. Take that curve away. Okay, so that looks good. Let's look at the end of the spout here. And again, let's check this off on an elevation. So again, it's a varying radius here. See if we can get a measurement across the perpendicular here. Now let's go to Analyze and Distance and just see what that distance is. Just turn on Project, so make that work properly. So 0.4 across the there, so probably it's something like 0.5 with a distance between rails. Let's try that to start off with. So solid, fillet edge, blend edge, 0.5, chain edges, pick the outer edge and enter again to go into preview. While we're in preview, let's just compare that with what's going on here. It's actually slightly bigger than that, so let's set all 0.65. okay, it looks a little better, and let's see if we can create something along the inside here as well. Now this is the area that is likely to cause us some problem here, so let's just see if we can go in and take a radius from here. We might need to actually go in here and extract an isocurve. Just toggle the direction here, get a more accurate idea of what the radius is. So it goes down to 0.2 there. So let's see what we can get away with here on this inside edge. Okay, so let's try and see if we can use the same radius as on the outside. Not quite. Let's try 0.5. That's fine. So let's accept the 0.5 radius there and just check first of all that this is still solid. We can just check this off now in the object properties, and let's just have a look with an environment map here. Okay, that's good. So that looks reasonably smooth. So apart from the top edge now, we're all done. So let's take a look at the top edge. Turn on the CAD again and see what radius we have here. Again, that's a blend, and we're going, that's probably from 0.7 there, so it's probably something like a 1mm blend. Let's try that. And while we're in preview, just have a look at that. It's a little bigger than that. Not as big as 1.5. Let's try 1.3. Still too big. 1.1. 1.2 is pretty close. Okay, so that looks good as well. So this is looking nice and crisp now. Everything's joined together as a solid. I'm going to just leave these parts until we actually do the lid surface. So let's now take a look at creating the lid. Now we already have the main top surface and the inner surface for the lid, the curved surfaces. So let's just take a look at the detail that we require here. The outside boundary of the lid is going to have an elliptical shape to it, and then it's going to have a sort of a projection which is D-shaped, which sits inside of here. So let's look at creating the outer boundary first of all. So before I do that, I want to check my elevations in place, and I want to look in my right view here and just turn off the surfaces. And this is the kind of general detail here. So what I want to create first of all are these two surfaces here. So this edge and this edge here. And I can draw these just with a couple of lines. Now I just want to check first of all that this distance here, this recess distance, is consistent here, because the CAD's a little bit shaky around here, as you can see. So that's okay. It's a consistent distance of 0.41. So what I can actually do is draw directly over the top of this CAD. And I'm going to turn off my elevations in place, and I'm going to connect these two curves. So I've already created a layer here called lid detail, which is on my surfaces. I'm going to turn this on and make it active. And one of the nice things about rail revolve is that the rail and the cross section don't actually need to touch each other. So to create my elliptical outer edge of the lid, I can use this profile curve that I've just drawn, and I can rail revolve this round the existing ellipse that we used to create some other parts of the geometry. Type 0 in the front view here and just draw the axis vertically, and then I can turn on the outer lid surface and I can trim these up with each other. So I'll just turn the curves off temporarily. Okay, so join these together. Just check by turning on the other surfaces here that this fits correctly. That looks good. Obviously, the merit of building this part and this part from the same surface is that we'll have perfect continuity across them. Then we can look at putting the general D shape fitting into here. So if we go to our top curves, and just look at this in plan view, let's turn off the surfaces. We can see the D shape that we used for the main body of the pot, for the cutout in the top of the pot. So of course we need a clearance between here, and I need to consult my elevations in place to see what that might be. It's 0.75, and let's just check it's consistent on this side. Okay, so it is. And we need to check this distance across here. 2.83. 3 there. So a little bit of inconsistencies there. Let's make the this feature 3 millimeters. So I'm now going to look at creating the offset of this D shape. I need to create two offsets, the first one at 0.75, second one at 3 millimeters. I'm going to use the standard offset here, which is to a tolerance. And if I use the absolute modeling tolerance here, which is 0.001 of a millimeter, I'm going to have a curve that's very, very dense. Okay, I probably don't need to offset to that accuracy, so I'm going to reduce this by 1 decimal place here. So I'm going to offset to 0.01 of a millimeter, and my distance here is 0.75. Okay, and you'll see the slightly fewer control points here. My next offset is 3 millimeters inwards from here, but rather than offsetting the previously offset curve, we're going to offset the original curve by 3.75 millimeters. Okay, the reason being that again, if I offset this curve, that's got quite a few control points into it, I'll get even more points here, whereas I offset this curve that's cleaner, I'll have fewer points here and achieve the same accuracy. So we've now got our offsets, and I'm going to highlight these two curves here and turn on my elevations in place and just pull these down to their correct base position. So I'm going to use the move tool, hit tab to constrain the direction, and then snap to here. Then I can turn on my surfaces, turn off my elevations in place, and I can pick the outer of the two offsets here and use a extrude surface with the extrude curve with the straight option. Make sure I do this on the right layer and pull this upwards, just make it slightly overlong, and then take the inner curve, which is here, and extrude this up slightly higher. Turn off the curves layer, and then I can just extract this surface and create an intersection curve between these two, and use that to trim with. So I want to trim away that surface there, and then that little piece of extrusion there. So I can join the outer part of the lid together. And now let's show the lid surface inner, hide the outer part, and trim these with each other. So use an intersection curve, and create the trim. Just get rid of my intersection curves here, showing the other components. Okay, and then I can just go to this view here and go to surface from planar curves and just select those two boundaries there, and then hopefully I should be able to join everything together into a closed poly surface. So that's the main part of my lid. I now need to just create the small D shape at the back of the lid. So if I turn on my elevations in place and have my cross section and my plan view on, we can see this D shape here. Just going to try and take a radius from this here. If this is coming from Illustrator, this won't be, there's a good chance that this won't be circular. It'll be a spline, it'll be a Bezier. So it's around about 7.5. So I'm going to turn on my top curves here, draw a circle with a radius of 7.5 millimeters, and I'm going to just position this. I'm going to snap to my intersection or quad point here, hit the tab key and snap to the front of that. And let's look at moving this up in this elevation to its correct position. So you can see it's not quite in the correct position here. There's a discrepancy between the plan and the elevation. But I'll just extrude this. I'll turn on the lid detail, and I'll extrude this. And I'm going to just put a cut through this. We just shade this up here. Ghosted mode would be better. I'm just going to take a straight line through here and trim straight through this, and then cap that surface. Okay, and then turn off my 2D curves and elevation in place. And this is what we've got here. Okay, so again, I can chop through here and relieve the back of that, cap this again, and then I can union these two together. Okay, once these have been unioned, you can clean up these coplanar faces here by going to Solid Tools and running Merge All Coplanar Faces. And let's just remove any unwanted curves, and we've now got that feature well and truly in there. Now all that remains now is just to add some small blends and fillets just to soften these areas. So I'm going to turn on the main body components here, and I'm just going to add a pair of blends at the top here. Now these probably don't need to be very big. Let's try something like a 0.5mm blend. And I'll use distance between rails here to keep this reasonably small, and shade that up. And just run an environment map to see what this looks like. Okay, I think that looks quite nice. Okay, and let's just then concentrate on this, and we'll put a slightly bigger, we can just use a fillet here, a 1mm fillet around this edge here. And then let's concentrate on these two here. So let's put a fillet here, and let's make this about 5mm. Okay, and that means that we should probably have a 2mm fillet on the inside face of this as well. Just check here that this is still closed, that we haven't opened up anything inside here by filleting. Okay, so while I still have it fresh in my mind that I've used a 5mm radius there, I'm going to go to my layers here and put a 5.75 fillet here. So that's with the 0.75 clearance. Go back to the lid detail, and let's just soften off this area around here. So I'm going to put a 2mm fillet down this edge and the corresponding edge over here, and a 1mm fillet around these other two edges, and I'm going to build them all at the same time so I get a good corner condition. So go to Solid, Fillet Edge, start with the 2mm radius on those two edges, and then a 1mm radius on these two. Check the preview and enter to accept. Okay, so next up I need to just fillet these three remaining edges. First of all, I'm going to put a 0.5mm fillet on this inside edge here, and on this edge here. And then here I need to put a reasonably large radius. So let's start with about 1.5 here, and I use my chain edges option and go into the preview. Just going to increase this slightly. The reason I want this edge to be soft here is I don't want this edge to stick inside the corner of the lid. So I want to open this edge out as much as possible, to soften it off as much as possible. Okay, that looks quite good. Just check this with an environment map. Looks fine. And then let's look inside the pot itself and just fillet off these edges. So I'll put a 0.5 on this edge. So this is the edge here where on the lid I've got the large radius to make sure that we don't stick in that corner. And then I can put a larger radius here so we don't have the same problem on this face. So let's maybe make this 1.5 and use the chain edges option. And that looks fine. Okay, we could put a smaller 0.5 radius on this edge if we wanted to as well. Just check that this is still all closed and check with the environment map. Okay, that looks good. So the last remaining task now is just to model the handle for the lid. So I'm just going to turn off the body surface and then just turn on the elevations in place again. And the lower part of the handle here is ceramic, and then the top is like a metal disc. So we only really need to model this boss on here. So I'll go back to my curves layers here and top curves, and I can just trace over this with a line. Just check the thickness here. Okay, so that's 3 millimeters. So turn off the elevations in place and just turn off temporarily the lid detail, and I'll just connect these two lines, and I'll just draw a straight line up from 0 and just trim this. So I can offset this by 3 millimeters. And I can just revolve these two. So I'll go back to my lid detail here. And choose a revolve. Turn off the project constraint. and just revolve those two components. Turn off my curves and just temporarily extract the top surface, and just with my visibility tools I'm just going to invert selection and hide objects, create an intersection curve here, trim these away with each other, and join, and then show the remaining objects, temporarily extract the inner surface, and repeat this process here. Curve from objects, intersection, trim, and join. Okay, so showing all of the geometry now. Join everything together, check that this is a closed poly surface, and then we want some very small radii around here. Let's just check against the elevations in place what they should be. It's a 1 millimeter radius and 0.5 on the top. So I use a blend edge here, 1 millimeter. And then a 0.5 around the top. And then here we should have the 1 millimeter plus the wall thickness. I'll use a fillet here. Don't need the complexity of a blend. And we just need to make sure that this is going to build correctly here. Okay, that's fine. Just remove that curve. Okay, so that's the lid detail created. And now we can just create the top handle. And again, this is really just a disc of a given thickness on here. So I can turn off the side cross section. I just need the side elevation on, and you see the disc just sort of sits over the top of that handle. So that is the radius for the disc. Let's move this up into position. Okay, and then extrude that. So finally we can just put some small fillets on the top and bottom of this, and just to make it look as though this ceramic piece fits into the metalwork here, just going to do a Boolean difference, making sure delete input says no here, and then I can just hide the lid detail, put a very small fillet here. Okay, and then that will make that look a little more convincing now as we look up there. Okay, so next up we can turn on the surfaces, and let's just do a quick visualization of this to finish off. Just create a new set of layers here, call this V-Ray, and create a new sub-layer, call this Studio, make it active. Okay, so I'm just going to use V-Ray at its default settings here for this. So I'm going to go to V-Ray, go to my options, go to global switches, and make sure that my defaults are loaded. The only setting change I'm going to make here is that I'm going to uncheck override viewport. Everything else is going to be at default settings here. So I'm going to load a V-Ray ground plane, and I'm going to use V-Ray Express to just create some materials quickly. These two components here, I want to have a white porcelain, and then this component here can be a blurry steel. And then the ground plane, I'm going to use the wrapper floor material. So let's now check this out in V-Ray RT, and this will look fairly sort of uninteresting at the moment. So let's use here a V-Ray HDR environment, which is a combination of a dome light and an HDR, to give this some additional improved illumination. And these standard environments that come with V-Ray Express, really quite nice. You can see that this is bringing really nice subtle lighting to this. So we can probably go back to shaded now and do a production render of this at a larger size. So there we go. That looks fairly good for a starting point with a basic render. So that's just at defaults with one of the HDR environments and dome lights that come as standard with V-Ray Express used. So really almost no setup whatsoever to get this rendering. Thanks for watching, and please do check back for more Simply Rhino tutorials.